Viewers, welcome to the YouTube channel H2O Chemistry. In this video, I'm going to talk about the extraction of aluminium by Heroult process. If you directly come to this video, I recommend to watch the part 1, that is base process, to understand this video much better. As I told you, it is a part 2 video. We will see what is called Heroult process, which is otherwise called electrolytic reduction of alumina. Alumina we have concentrated in the base process, which is nothing but aluminium oxide. What do you call electrolytic reduction? We use electricity and we break the molecule of alumina. What is called reduction? Removal of oxygen is called reduction. So from the alumina, we remove oxygen by breaking the aluminium oxide bond. Aluminium, oxygen, we have a bond in between. This bond we are breaking electrically and we are removing oxygen. So this process is called electrolytic reduction, which he has called as Heroult process, otherwise called as Heroult process. Now, what is the apparatus setup? It is an electrolytic tank. You could see here the electrolytic tank, which is made up of iron or steel cell. The inner wall of the steel is lined with graphite, which is usually a good conductor of heat. We call gas carbon or graphite is lined in the inner wall of the steel cell, right? Which is connected to the negative end of the battery, so which act as a cathode. Now, there are some graphite rods are hanged parallelly in the electrolytic tank, which are clamped in the copper, the top of the electrolytic plate, electrolytic cell. In this anode graphite rods can be moved up and down depending upon the extraction. That means if the graphite needs to be immersed into the solution, we can immerse by just moving down this graphite rods. The process is over, we can take out of this graphite rod out of this electrolytic cell, so which we can be moved up and down. Now, the temperature maintained in the electrolytic cell is around 900 to 950. The reason we will see in the later. The voltage applied to this is around 5 to 6 volts, very minimum volts for about 10 amperes we will supply. What is the electrolyte we take? We take fused alumina, so which is available, which is extracted from base process. Fused alumina, 1 part by weight we take, and cryolite. Cryolite is nothing but Na3Al6. That is called cryolite. 3 parts by weight, molten cryolite they said, and then fluorospar, which used for reducing the fusion temperature, CaF2, which is 1 part by weight. 1 part by weight. So we take this mixture as an electrolyte solution in this, which is fused. So when around 950 degrees centigrade is maintained, this whole mixture is converted into liquid. We call molten state. We call fused state. There is a opening at the bottom of the tank to remove the molten aluminium out. So this is the apparatus setup. Now, what is the reason we are not using only aluminium oxide? Instead we use this cryolite and fluorospar. So there is a reason behind this. Alumina is highly stable oxide, which melts at 2050 degrees centigrade and then it conducts electricity. So a lot of electric current or electrical energy need to be supplied, and a lot of heat energy to be supplied so that the alumina to melt. Once the alumina is heated to 2050 degrees centigrade, and by passing electricity, if you remove aluminium, what happens? The aluminium volatilizes because the melting point of aluminium is 660 degree only. If you at a high temperature 2050, what happens? The aluminium volatilizes as a vapor, so we cannot get the aluminium. So we are not using alumina alone as an electrolyte. Instead, if you add with the cryolite and the fluorspar, what happens? This mixture melts as 950 degrees centigrade instead of 2050 degrees centigrade. So the consumption of electricity is very less. The amount of energy, heat energy we use is also very less. What is the role of this cryolite and fluorspar? We will see. The role of cryolite is increases the conductivity of the mixture and helps in saving energy. So once this mixture melts, you supply electrical energy. The cryolite helps to conductivity so that the electrical energy can be, the mobility of ions can be done very easily. Which we call conductivity. Similarly, fluorspar. Fluorspar, CaF2. CaF2 is added as a solvent for dissolving this cryolite as well as alumina, and which lowers the fusion temperature. So instead of melting at 2050 degrees centigrade, the mixture melts at 950 degrees centigrade. So a lot of heat, electrical energy is saved. So that is the use of this fluorspar, and which also increases the mobility of ions. The ions like Al2O3, Na3, Na plus, Al2F6, AlF6, Na plus, sodium ion, aluminium ion, calcium ion, all this can be moved very easily when you take this fluorspar. So it increases the mobility of ions across the electrodes, right? So this is the whole setup. Now you just see this. The graphite rods are connected to the negative end of the battery, so which is called as anode, which can be immersed in the solution. Here the graphite is lined in the inner wall of the steel cell, electrolytic cell, which is act as a cathode, right? So which is connected to the negative end of the electrode. Now, what you have to understand? Once we take this mixture as an electrolyte, if you maintain 950 degrees centigrade, the whole mixture melts. Now, the graphite rod, anode rod, is immersed into the molten electrolyte. Now, the current for about 5 to 6 volt is passed in the electrolytic solution. So what happens? The aluminium is positive, oxygen is negative. So aluminium is attracted towards the inner line of the electrolytic cell, which is made up of graphite, because it acts as an anode, so cathode. Cathode is negative, the aluminium is positive. So once we take the aluminium process, so the minus, the Al3 plus will come and get the electrons from the cathode and deposit it as a aluminium metal. So it's once this process keep on is going on. What is the negative part? Oxygen is a negative part. Oxygen 2 minus, O2 minus ions move towards the anode, which is plus. Once it moves there, it loses the 2 electrons and becomes nascent oxygen, atom of oxygen, one single atom of oxygen, which is very reactive. You could see this equation. The O2 minus migrates towards anode and loses electron to form nascent oxygen. Attacks carbon. Once carbon and oxygen combines, it forms carbon dioxide, and goes as a bubble, so you could see clearly. Or the oxygen combines with one more oxygen to form oxygen molecular oxygen. So there are two reaction happens at anode. The nascent oxygen combines to form O2, or the O2 combines with the carbon, or it burns, the anode burns so that the carbon combines with oxygen to form carbon dioxide, which usually go as a bubbles. Now actually what happens? This graphite rod, the oxygen come from the electrolytic solution will combine with the carbon to form carbon dioxide. So the carbon is slowly evaporating as a carbon dioxide. So the rod size will become decreases when time passes, because when the keep on oxygen is reacts with the carbon in the graphite, so the graphite rod size is reduced when we pass electricity time to time. What happens? Once all the graphite is used, all the carbon is used up, we need to stop this process and we have to take out this rod and we have to insert a new graphite rods, and then we have to immerse this new rods into the electrolytic solution, and then we have to continue this process. Now, the aluminium moves towards graphite and take up the electron and will settle at the bottom of the tank, because at 950 degrees centigrade the aluminium melts as a liquid, because the melting point of aluminium is 660 degrees centigrade. So it easily melts at 950 degrees centigrade and settles on the bottom, which is often removed from the tap. You could see the tap here. So once the aluminium is over in the electrolytic solution, the bulb glows. So when the bulb glows, the aluminium in the electrolytic solution is less. So we will add a fresh alumina mixture so that the process can be continued. So the molten aluminium is taken out in a separate container and we can use it for our malleability or the sheets or drying wires. So this is how the aluminium is extracted electrolytically in the Heroult process. The overall reaction, if you watch, 2Al2O3 gives 4Al and 3 oxygen molecules. Here the aluminium is collected at the bottom of the tank in the graphite, which is act as a cathode. The oxygen goes to the anode and combines with the carbon and forms carbon dioxide. But the overall reaction, if you see, 4 aluminium and oxygen is separated. So it is a reduction process, removal of oxygen takes place. I hope this video is very helpful in understanding the process of extraction of aluminium from alumina, which we call Heroult process or Heroult process. If you like this video, subscribe and click the bell button to get the notification instantly. Like, share it to your friends, comment if you have doubt. Thank you.